There you go. 520. Boom! Back to life. Oh, you can see it. You can see on my voltage current here at the top. That's it. Hey, what's up, guys? This is Juan from Engineering Room one more time, and we have another repair. I have here a A1708. This is a MacBook Pro. This year is 2016, 2017, without no power issue. So, oh, I bad here. So, if the first thing we're going to check is the power supply. So let me show you here. Perfect. So let's check our power supply. Here. Wait. Right there. What's our current? How many amps is the board taking? Okay, it's just taking it here. I'm getting around. If I disconnect it, let me turn off this. Okay. So we have is 1675. 75 minus 16 is 59. Yes, 5960 milliamps. Here, okay, let me show you guys. I think the best way to show you is like this. In this port, is taking 130 milliamps. Okay, if I change it to this other port, is taking 330 milliamps. Why? I'm not sure. That's what we're gonna check. Because this reason, because in the port is taking different milliamps, different current. That's why I decide to make this video. So I believe there's a short circuit in somewhere close to the CD3215C, but not sure yet. So what we're going to do is we're going to connect them in both ports, and then I'm going to use my thermal camera. My bad. And we're going to check. Let me drink some water. And we're going to check if there's any short circuit. So let me check. Where is my I think it was last time I used it was this morning. There you are. Yeah, I used it this morning. So we're gonna check right now, right? Okay. The first thing we're going to check is like this. This is my ports R. This one first. Come on, take it. This USB tester is so bad. There you are. So okay, it's showing me in the first one. Okay. Now let me check the other port. It's checking me the same. Okay, so no matter what, we have the short circuit in this AC. Now, why is we want port? Because on the port, this one is 132. So this IC belongs to this port. So it's closer. That's why it's taking more. Yeah, there's. So, what we're going to do, let's now check. Okay, there you are. So the short circuit will happen in this port. Okay. So let's say that someone doesn't have a thermal camera. What's my recommendation? You try, okay, and then you see, okay, I'm 5 volts on one is taking 300 milliamps and the other one is 130 milliamps. What would I need to do? My recommendation is doing this next step. I will go in diode mode, OL. You see that it goes to OL, it's open line. And then I'm going to check which lines do I have close to ground or which ones I have shorted. I have at 0. So let's start over here. Let's start here. So this, no, I can't believe it. This is ground. This is shorted. Let me see this. You see, so 0.600 milliamps is what that line is taking. So this one, for example, is 26 milliamps. So it's not good. It's not good. It have to be higher. So let's see which other lines are close to 0. This one is 0. This is good. Almost 0. This is good. Okay, so this one, and this one. So this one is PP1BA UPC-XALDOD. Then I have this one and PP3B3 UPC-XA. Oh, you guys are, I'm an idiot. I'm sorry. So we have this one, right? It's 1BA UPC. I have this one, UPXA I2C line. And then I have this one. So I have 3 different paths that they have nothing to do one each other, or at least a couple they're not. You see? This one and this one. So what I need to do next, I have 3 different paths, the 3 different lines that they are not related each other, besides that they're 3 related with the U3100. So in this case, what we're going to do, I'm going to remove it. Here, I'm going to remove it, and then we're going to see if they're still shorted. Looks it's not working, I don't know why. There you go. Now it's working. Let's move it. Okay, now it's out. I'm not sure it is the pad. I'm not sure it's the IC. I believe it's the IC. But let's check. You see? Now it's open. If I touch it together, it makes a sound. I don't know if you guys can see it, but check my multimeter reader. Open. This one is still shorted. Okay. And this one is open. So this one, R3102, have to be, oh, it goes to ground. So that one, it goes to ground. Okay, I didn't know that. UPCX I2C is a 0 ohms resistor to ground. Ground I2C. Okay, is the ground for the I2C address, I guess, ADDR. Primary only. Okay. However, the short I have in this one and this one is not present anymore. Now, before I put a new one, okay, what I'm going to do is I'm going to test that all my path is good. Okay, so let's go with the first two lines over here. My bad. So I'm checking. And none of this besides this one is to ground. Very quick. I don't want to surprise it. I don't want to have to remove it again after I put a new one. I want a solid repair process. Okay, so these 6 are good. Then I have 1, 2, 3, 4, 5. I had this one, this one, and this one. Oh, my bad. This one then. This one, and this one. Everything else is ground. Okay, this one, and this one. Okay, now let's everything at the bottom. Okay, I know there's, let me check. R3017, same thing. R3017, how you can see it here. This is a 0 ohms resistor that goes to ground. Okay, boost power. Okay, they're getting more electrons from here. Okay, so we're good with that one too. Let's keep testing it. So that one is this one. This one, my bad. Okay, these ones, they are not ground, but let me check this. 150 milliamps. I guess that's right. I'm testing with the other one. Same. Okay, so that's good. Now all this. Okay, and then from the middle. Okay, everything looks good. So what I'm going to do, I think I have new ones. If I don't have a new one, I'm gonna have to take it from another board. What we're gonna do right now is let's prepare the board. Turn on this. Okay. Now I'm gonna put my solder. Okay, now let's clean it. Almost done with the cleaning. Very careful. You don't want to scratch the board or remove anything. Just very careful. Not even making too much pressure in the board or to the board. Very soft. There you go. There you go. Now let's clean it. Put some fresh plugs and my board will be ready for the new IC or the all new IC. Let's see. And boom, clean process. Let me put some fresh plugs. Okay, board is good. Let me see if I have another IC. I think I have some over here. Yep. Now I think these have to be, yeah. CD3215. See, this is the bad one, the one we remove. Yep, this is the one. So these two have the same position. Let me confirm it on my schematic. Yeah, same position. So let's grab the new one. And here, let's solder it back. Let me move my camera over here a little more comfortable. Okay. Yep, it looks. There you go. Okay. Okay. The IC is in place. Let's leave it cool down a little bit, and then we will check. That board should be working now. Okay. There you go. 520. Boom! Back to life. Oh, you can see it. You can see on my voltage current here at the top. That's it. Bad CD3215C. That was the whole problem. Let's check the other port. Man, I have. Oh, there you go. Same. Now, how we're going to. I'm having problems with this. This disconnect is. So, let me organize this. It's too messy. Let me throw this. So, what we're going to do right now is we are going to check if I have USB activity. Wait. I'm going to need, I think, this. Yes, let me use this very quick. Oh, but I can't use this. Actually, what I need to do is not use this. We'll just use this one. And this. There you go. Now you guys can see it. This is. I think I can show you. The best way to show you is I connect it here. Yeah, that little dot. Oh, I disconnect. My bad. Is the dot of my USB. External USB. So if it start blinking, it means they have USB activity. There you go. So that's it. That's it. Now we're here. What we're going to do is, let me put it inside of the chassis. And let's test it. Okay, where's the hard drive? Right here. There you are. So what we're gonna do now, let's connect our power supply. Computer should be going on. There you go. I have the charging sound and I have a Apple logo. Okay, I don't want to show the user. I don't want to put everyone in the scope. So that's it, guys. It was a very short video. It was around 30 minutes, and it was a simple repair actually. But the important thing is how we can have an idea where the issue is. Okay, why? I connect the USB tester, and even with the power supply, but I saw it with this. So I saw that one port is consuming more than the other one. So I thought for a second, okay, this is not very often. Normally you have, if there's a short circuit somewhere in the logic board from PP positive hot or after, you have the same consuming in both ports. So what that means? It means that probably the short is very near that the USB 3215C, or it could be one of those. I didn't thought it was one of those. I thought it was a cap or something else that it have a direct communication, software or data with one of those IC. Okay, then I started the video, and then that's when we saw with the thermal camera, very important tool, that no matter which port do I use, the same IC is showing that it's overheating. Okay, then what we did, we tried in diode mode to check the first line that we touched. That line was too low. It was too close to zero. It means it's too close to ground. And there were, I thought 3, but actually was 2 different pads that they have no communication at all, and both were down, too low. One was almost 0, oh wait, focus is bad. There you go. One was 0.007, I think. The other one's around 24 milli. So at that point, I decided to remove it. Once we remove it, short disappear. Put a new one, computer's on. So very simple. I just want to show you that is if you go in the right way and use the right technique, hard repairs or logic board repairs can be simple. Okay, you don't have to be the most intelligent guy. I'm not. You only have to use the right technique and focus on the right way. Okay, so that's it, guys. This is one. I'm back with the videos. I spent the last 2 weeks working on something else related to my business. I'll explain you that later, but right now I'm back with more videos. So I should be posting another video in the next couple days. Okay, see you guys later. Bye.